In this video, we will be solving triangles using the law of sines, but we will be focusing on triangles where we are given the side angle set of information. This is called the ambiguous case because when you're given two sides and the non-included angle, you can't be sure if it'll make a triangle at all. And if it does make a triangle, you don't know at a glance whether it will make one triangle or two triangles. So we will need to use some special strategies. So as soon as I see that I have two sides and an angle, what I always am going to do is I'm going to draw myself a horizontal segment. All right, that's going to be the bottom of my triangle. And then I will form an angle on the left-hand side. And I will take the one angle I'm given and I will put it in there. So in this case, that is angle A. I will take the open side and I will make it a dotted line because this is the swing side. I'm thinking of this as a rope. I don't know if it will reach to form a triangle or maybe it will make two triangles. It's sort of variable, so I make it dotted. But anyway, if this is angle A, then that means this is side A, so the 2 will be here. The other side should be the rigid side. So I'm going to go ahead and put the 10 right here. But that's side B, which makes this angle B, which makes this angle C. All right, the first thing I have to do is find out whether or not this will make a triangle at all. The way I do that is by calculating the height of the triangle. Okay, so call it H. I can find the height by doing the sine of 45. Sine of 45 is going to be opposite over hypotenuse, so that's going to be H over 10. Multiplying both sides by 10, I will get 10 sine 45 is equal to the height. I'm just going to put this in my calculator real quick. All right, 10 sine 45. All right, I'm getting 7.071 for my height. Okay, so it's approximately 7. And I can tell right away that this is not going to make a triangle at all. I'm going to say no solution. All right, this will not make a triangle. The reason why it will not make a triangle is because we just found that the height of the triangle is 7. Now I'm looking at my rope here, and my rope is length 2. All right, side A is 2. Originally I had it stretched all the way across here, but now that I see that the height of the triangle is 7, it makes me want to erase part of this because there's no way that a rope of length 2 is going to reach the other side. Even if I stretched it straight down, again the height is 7, a rope that is length 2 will not reach the ground. So that's why I get no triangles, no solution. So we just move on to the next one. So looking at this one, again I have two sides and an angle. So what I will do is I will draw my horizontal segment and I will draw an angle on the left hand side and I will put a dotted line on the right hand side. I'm going to take my angle and put it in the angle. So that's angle A, which makes this side A. So that's why this will be 47. I will put my other side as the rigid side. So if this is side B, then this is angle B, and that means this must be angle C. So before I go any further, I have to decide whether or not this will make a triangle at all. So I need to calculate the height. So I can find the height by doing the sine of 44, which is opposite over hypotenuse, H over 65. Multiplying both sides by 65, I'm going to get 65 sine 44 is equal to h. And then I will put this in my calculator. So 65 sine 44. So I am getting 45.153 for my height. All right, so it's approximately 45 point, let's say 2. Is this rope long enough to reach the other side? Yes, it is. The height is only 45.2, but my rope is longer than that, length 47. So the rope will reach to the other side, and I will have at least one triangle. So now I have to ask myself, okay, fine, I have one triangle, but will there be two triangles? Here's how you get two triangles. Sometimes you can take this rope and swing it inside the triangle like this, and it forms a second triangle. So the question is, will this rope fit in here? Now remember that this is, the rope is length 47. So I look at the rigid side to answer the question. The rigid side is 65. So a rope of length 47 will fit. It's not too long. If this had been bigger than 65, it would stretch outside of the triangle, and I could not form a second triangle. But 47 is smaller than the rigid side, so it will fit in both places, outside and in. So I will have two triangles. So what you should do in that case is draw your second triangle separately. So I'm going to take this triangle right here, and I'm going to draw it over here. So that's going to be something like this. All right, so here is this angle that is 44. This is angle A. Okay, and now, so my swing side, here's my swing side coming inward. All right, now I cannot call this angle C this time. I have to call it C2 because it can't be the same as this. Similarly, I'm going to have to call this B2. Okay, now this is still going to be 65, and this rope is still 47. Whoops. All right, that rope is 47. And I will call this side of the triangle C2. And all right, so back on the blue triangle, I can erase some of this. And I think for my blue triangle, I'm going to call this C1 and B1 and side C1 to distinguish it from my pink triangle. So now I am all set. Let's go ahead and solve the blue triangle. So first let's make our solution box. I'm going to need to find the measure of angle B1. I'm going to need the measure of angle C1. And I will need the length of side C1. So once I find these three values, I will have solved the triangle. Let's go ahead and find angle B1. Since I'm looking for the angle, I'm going to put the angles in the top. So I'm going to do the sine of 44 over 47. And then I will do the sine of angle B1 over 65. So to get the sine of B1 by itself, I am going to multiply both sides by 65. These will cancel out. That will get sine B1 by itself. But I want the angle itself. To get the angle, I do the inverse sine of all of this. And that should give me the measure of angle B1. So I'm just going to put all of this in my calculator at once. I got 73.883. To find angle C1, I need to subtract these two from 180. That gives me 62.117. Now I'm going to find the length of side C1. Since I'm looking for a side, I'm going to put sides in the numerator. So this time I'm going to put 47 over sine 44. And that should equal C1 over the sine of 62.117. To get C1 by itself, I need to multiply both sides by the sine of 62.117. All right, that way these will cancel out, and that will give me C1. So put all of this in your calculator at once. That's going to be 59.804. So that's it. We have solved the blue triangle. Now we need to move on over and solve the red triangle. So here again, let's write out our solution box. We need to find the measure of angle B2. We need to find the measure of angle C2. And we need to find the length of side C2. Once we find these three things, we will have solved the red triangle. Now, here comes the thing that's slightly different. When we find this obtuse angle B2, we cannot find it in the same way that we found B1. We can't use the inverse sine, because that's just going to give us the acute angle of 73.883 all over again. Inverse sine will only give you an acute angle. But luckily, we can get this obtuse angle B2 by looking at the acute angle B1. These two angles will always be supplementary. So if I want to find angle B2, I can just do 180 minus B1. So angle B2 is going to just equal 180 minus 73.883. That yields 106.117 degrees. To find angle C2, I need to subtract these two from 180. And that is 29.883. And finally, I can find side C2. Because I'm looking for a side, I'm going to put sides in the top when I set up my law of sines. So I'm going to say 47 over the sine of 44 is equal to side C2 over the sine of 29.883. To get C2 by itself, I need to multiply both sides by the sine of 29.883. In this way, these will cancel out and leave C2 by itself. So I'm just going to put all this in my calculator at once. And that's going to be 33.710. And that's it. We have solved both triangles. We found the red triangle with the obtuse angle B and the blue triangle with acute angle B. All right, let's keep going. Again, I see that I have two sides and an angle. So this could be side-side angle, the ambiguous case. So I will set it up in my special way where I make a horizontal line and then I put an angle on the left side, and inside that angle I put the one angle that I have, 45, and across the open side I put a dotted line representing the swing side, like a rope. So this is angle A. That makes this side A, which is 5. The other side will be the rigid side, the non-moving side. If this is side B, that makes this angle B. So this must be angle C. Before I do anything else, I need to decide if this will make a triangle at all. I will decide that by calculating the height of the triangle. The height can be found by doing the sine of 45 degrees, which is opposite over hypotenuse, h over 4. Multiplying by 4 on both sides gives 4 sine 45 is equal to the height. I'm going to just put this in my calculator real quick. 4 sine 45. Okay, that is giving me 2.828 for the height. All right, so it's approximately 2.8. So, will the rope reach the other side? Yes, the height is only 2.8, the rope is 5. So the rope is long enough to reach the other side. So far that means there is at least one triangle. The question is, will there be two triangles? Well, we get two triangles when you can swing the rope inside like this to form a second triangle. So if I swing this rope inside, will it fit? That's the question. Its length is 5. Well, look at the rigid side. The rigid side is only 4. So if I have a rope of length 5, it's not going to fit underneath this. It's going to stretch outside the triangle. So it will not fit inside. So the swing side can only fit outside. So we will not have two triangles this time. We will only have one. And it will look like this. Okay, so the rest of this should be pretty straightforward. What are we missing? We're going to need to find the measure of angle B and the measure of angle C and the length of side C. And when we find those three things, we will have solved the triangle. Let's find the measure of angle B. Since I'm looking for an angle, I'm going to put angles in the top. So I'm going to say the sine of 45 over 5 is equal to the sine of angle B over 4. I want to get the sine of B by itself, so I'm going to multiply both sides by 4. The 4's cancel out. That gives me the sine of B. But I want angle B itself, so I'm going to do the inverse sine of all of this. And that will give me angle B. So put all of this in your calculator. That is 34.450. So to find angle C, I'm going to subtract both of these from 180. That is going to be 100.55. So to find to find side C, I'm going to do the law of sines. Since I'm looking for a side, I'm going to put sides in the top. So I'm going to say 5 over sine 45 is equal to side C over the sine of 100.55. To get C by itself, I need to multiply both sides by the sine of 100.55. All right, these will cancel out, and then I will have side C. So I'm going to put all this in my calculator at once. That turns out to be 6.952. So that's it. We have solved the blue triangle, which was the only triangle that could be made. All right, let's do one more. Once again, I see the infamous side-side angle happening. So I am going to draw my special drawing where I make a horizontal segment for the bottom of my triangle, and I put my angle on the left side like this. All right, so this will be angle B, and this will be 38 degrees in here. Across the open side, I'm going to put my swing side, my rope. And so if this is angle B, this is side B, which is why I'm going to put the 8 here. The other side needs to be the rigid side, so I'm going to put the 10 here. If this is side A, that makes this angle A, which makes the other angle angle C. Before I go further, I need to check and make sure that I can make a triangle out of this. And the way I can check that is by calculating the height of the triangle. I can find the height by doing the sine of 38, which will equal opposite over hypotenuse. Multiplying by 10 on both sides, I have 10 sine 38 is equal to the height. Punch that in your calculator real quick. And I am coming up with 6.157 for my height. All right, it's approximately 6.2. Will the rope reach the other side? Yes, it will. The height is only 6.2. The rope is length 8. So that is long enough to reach the other side. So that guarantees there will be at least one triangle. The question is, will there be two triangles? The way you get two triangles is sometimes you can swing the rope inward, and if it fits, it will make a second triangle like this. So the question is, will the rope fit inside the triangle? And yes, it will. I'm looking at the rigid side. That's length 10. Because the rigid side is longer than the rope, then that tells me that the rope, which is only length 8, is short enough to fit inside the triangle. If this rope were longer, if this rope was length 10 or 11 or 12, then it would be too long and it wouldn't fit inside the triangle, and I'd only have one triangle. But because it is long enough to reach, but yet short enough to fit in the inside, I can make a triangle in both of these positions by swinging the rope back and forth. So, because I'm going to have two triangles, I'm going to need another drawing. So I'm going to draw this triangle that has this position. over here. All right, so this is that angle B, that is 38. And this is still the rigid side of 10, and this is still 8. However, this angle must now be called C2 because it's not the same size as this. And this angle A should now be called A2 because it's not the same size as that. And as a matter of fact, when I go back, I think I'm going to call these blue ones C1 and A1. And we will need to find side C1 as well. In fact, let's go ahead and solve the blue triangle, starting with our solution box. So we're going to need to find the measure of angle A1 and the measure of angle C1 and the length of side C1. Once we find those three things, we will have solved the triangle. Let's start by finding angle A1. Since I'm finding angles, I'm going to put angles in the top when I do the law of sines. So I'm going to say the sine of 38 over 8 is equal to the sine of angle A1 over 10. To get the sine of A by itself, I need to multiply both sides by 10. That way these 10s are going to cancel each other out. That gives me the sine of A1. But I want the actual angle A1, so I need to do the inverse sine of all this. And that will give me angle A1. Put all of this in your calculator at once. That turns out to be 50.316. To find angle C, we subtract both of these from 180. And that is 91.684. Now I can use the law of sines to find side C1. Since I'm looking for a side, I'm going to put sides in the top. So I'm going to say 8 over sine 38 is equal to C1 over the sine of 91.684. To get side C1 by itself, I need to multiply both sides by sine 91.684. That way these are going to cancel each other out. Put all of this in your calculator at once. That's 12.989. So we have solved for the blue triangle, but now we need to solve the red triangle. Let's start by forming our solution box. We need to find the measure of angle A2, the measure of angle C2, and the length of side C2. Once we find these three values, we will have solved the red triangle. Now, we will have to find this obtuse angle A2 in a different way than we found the acute angle A1. We found the acute angle by doing inverse sine, but inverse sine will only give us acute angles. It will not give us obtuse angles. Luckily, we can find the obtuse angle A2 by subtracting the acute angle A1 from 180. In other words, when the swing side forms two triangles, the acute angle and the obtuse angle are always going to be supplementary. So I can find angle A2 by doing 180 minus A1. So that's 180 minus 50.316. And that is 129.684. Now we can find the measure of angle C2 by subtracting both of these from 180. That is 12.316. Now I can find the length of side C2 using the law of sines. Because I'm looking for a side, I'm going to put my sides in the top. So I'm going to say 8 over the sine of 38 is equal to side C2 over the sine of 12.316. To get C2 by itself, I need to multiply both sides by sine 12.316. That way these will cancel out. That's going to leave C2 by itself. So all I have to do now is put all of this in my calculator at once. And that is 2.772. So there we have solved for the red triangle and the blue triangle. So we got our two solutions. And that's going to do it for this video. I hope it was helpful, and I hope to see you on the next video.